Hey guys, what's up? Let's do a quick mic test. Let me check if I've connected the microphone. Sorry for the last minute thing. I wanted to do this way earlier. I was just super busy. Um, Camera, built-in microphone. It is the wrong microphone. Now I think the audio should be much nicer. I'm getting comments. It's 10:07. Where, sir? 5 viewers, poggers. Sir's here. What's a pogger? Hey guys, what's up? I can hear myself. I shouldn't have. Let's do a quick mic test. Let me check if I've connected the microphone. Sorry for the last minute thing. I want. Okay, that's what I sound like. Ciao. Okay. Okay, we'll do. So the idea is we'll do some questions. Now, there's a bit of lag, all right? Like whatever I say or do, there will be a 7-second delay. Sorry, 20-second delay. So if you have a question, make sure you like write that properly. And once I see it, I'll try to answer that question. Now, my idea is I'll try to go over questions. I'll try to solve them. Now, this is for people who might still be struggling. 1.6, what's 1.6K? Anyway. So the idea is that I'll try to explain a question how to do it. So it might take me longer than it should an average person. But yeah, well, not the average person, but I'll try to explain it. But yeah, I think that's the idea. But if you have questions, keep piling them up. I'll try to answer them. ठीक है. And again, sorry, it's just so incredibly last minute. I wanted to do this like 2 days ago, but just really busy. But something's better than nothing. And with that, let's start. Okay, in which rows are substances correctly classified? So you have an element, a compound, and a mixture, right? So now I think if you're in my shoes, we haven't really discussed brass yet, what brass is, right? But everyone knows what water is, and everyone knows what sulfur is. Even if they don't, if you're a slightly bit familiar with the periodic table, you can see it, sulfur show up, right? Now, what is sulfur? Sulfur is a pure element because it's in the periodic table of elements. It's going to be, sulfur is just, I think it has I don't know how many protons it has, but I think it has a mass of 32. And I should open the periodic table, I think. Should I? Why not? And you can see that on the periodic table, it just has a 16 protons. ठीक है. And sulfur is correctly categorized under elements. ठीक है. Now brass, if you're unsure, now those of you who are unsure, I think a lot of people already know what brass is. You know for sure that water is a compound because you've drawn water so many times, you know what it is. Who doesn't know what water is, right? So it's a compound because there are two different elements chemically bonded, so that makes it a compound. And if you take closer notice, you don't even have to worry about brass because that's all you see. If you get the first two right, that sulfur has to be an element and water has to be a compound. You don't even have to worry about brass. But brass is a mixture, it's an alloy. An alloy is just a mixture of metals. But if you don't know that, and I think people just find that part confusing. Okay, let's continue. Which molecule contains only single covalent bonds? First, what I'll do is I'll get my pink out. Single covalent bonds, what is it exactly trying to ask? So if I take a look at chlorine, this is what chlorine looks like if I just draw its bonds, bonded ones. Then I have carbon dioxide, and how is it bonded? Now carbon is in group 4, and if I try to work my way with the dot and cross for this, I'll realize it makes 2 bonds each with each of the oxygens. So a total of 4 bonds because it's in group 4. Oxygen makes 2 bonds because it's in group 6. And same for over here. So it ends up making, so far, chlorine's winning with only one single bond. It contains only single bonds. What about nitrogen? Couldn't that have a single bond? Now nitrogen is in group 5, and to have a complete outer octet, it has to form 3 bonds with the other nitrogen. That's what the bonding looks like in nitrogen. Okay, I hope this is making sense. I'm going slightly faster for this question because I think it's a little straightforward. Okay, and this is what oxygen looks like. It has a double bonded one. How do I know it's double bonded? Again, I'll draw the dot and cross for oxygen at least. There are two oxygens. Each oxygen will have 6 electrons in its outer shell. How do I know it's 6? Because it's in group 6 or 16. Okay, once I know that, what's going to happen is, remember the octet rule? They bond related to the, or keeping the octet rule in mind. They really want to have 8 electrons in their outer shell. Which ones? Both oxygens. And what do? They're going to share. So when oxygen shares its 1 electron, let's say this, why am I picking the wrong color? Wrong tool every time. And if you bring it in the center, that's what it means, right? Like they're sharing. So this is one bond made, and I'm not drawing the outer orbital for oxygen, but pretend it's here, kind of like that. I'm not making it because it's going to look very untidy. So over here, you see 2 electrons are being shared. So this oxygen has a total of 7 electrons, and this oxygen has a total of 7 electrons. Is it happy with it? Not yet. It wants 8. So it tries to share another one in hopes that the other oxygen will also share one more. And you got 8 electrons each. This is the same process you do for all of them over here, right? But I think over time you just get a little faster, so that's why I skipped ahead and just drew the bonding. Does this make sense to everyone? Any questions related to this? Guys, let's keep the discussions to chemistry only. I don't want people missing out a question because there were too many people talking. But I'd love to see some, comments on my hair or some hellos. Hi Ajwa, how are you doing? Okay, none of that game talk or anything, please. ठीक है. I don't see a question yet, but if you have a question, please capitalize your questions. I don't remember, but it's meant to give you, it's slightly less, the paper is designed to be finished in under slightly less than 90 minutes, right? Because you're getting 90 minutes to solve the paper. So it's designed to be solved in around 80 to 82 minutes. So you get that much. I don't remember the marks, honestly, because I made it like 2 weeks ago. But that's not a question you should be asking. Okay, RF value. Chromatography. This looks like a silly thing. I was debating whether I wanted to put this. How many of you hate chromatography? Show of hands. Anyway, paper chromatogram is given below for 4 different dyes. It's asking which of these dyes has an RF value of 0.7. Now this is going to be much easier. I can do a Zoom meeting. Actually, I don't want to. Can you start a Zoom meeting instead? It's too late for it. Like, no, I don't know. I'm just doing this as a like, hey, if you have questions, go ahead. ठीक है, I don't really want to start a Zoom meeting. ठीक है. Okay. So this question is much easier solved. What you're going to do is take a scale, make sure you have your proper stuff with you. Calculator, pen, pencil. By the way, a lot of people were asking for calculators or this and that. I'm going to show up tomorrow. If I find out someone's borrowing a calculator or something, there will be shoes thrown tomorrow, right? Stop being that person. Come on, like, get your exam set ready, right? I don't know, like I just got slightly annoyed by the amount of people who keep asking calculators and basic things. I know calculators fail. Some of those, I'm just like, never mind. Okay. What you should do over here is for all these 4 dyes over here, let me highlight them. For this one, for this one, for this one, this one, and let's take red or pink, whatever this is. This one. You have to figure out the RF values. How do you find the RF values? You take the distance traveled. The RF value is distance, that's too thick. RF value is distance traveled by the solvent, the distance, divided by the distance traveled by the, sorry, what am I saying? Distance traveled by the dye. This mark is the dye, or like the solution you're trying to measure, its RF value, and the distance traveled by the solvent. I mixed it up slightly earlier, right? So if you recall, this is the distance traveled by the dye. They can't show it, so they made a dotted line, right? And this is the distance traveled by the each different chemicals, or the dye as we call them in this particular case, because they're colored. Dye is just a speck that's colored. This is chromatography, Disha. ठीक है. And Disha, if you're confused, this is all more or less all you have to do. It's just this equation. RF values, chromatography, this is part of separation techniques. This was the last bit. ठीक है. So what you do is, the solvent, what you'll do is you'll take a scale and you'll measure this length. That'll be your solvent value over here. And then for A, you'll figure out this distance to the best of your ability. Now this is a bigger mark, right? It's not accurate. So just take the exact center value if you can and use that. Now figure this length out, and this length is going to calculate, this will be the dye, distance traveled by the dye, right? And this is distance traveled again by the solvent. And I think just by a good guess, I think you're gonna get something like 0.85 for this. I don't have a scale with me or an app of a scale that can do this. This is gonna come to very close to 0.6 or slightly less than 0.6. This is gonna come out to 0.1 or 0.2. Now this, I'm pretty sure, I could be wrong though, but I'm pretty sure this is gonna come out to 0.7. But if you do it right, you're gonna get the right value. And how do I say that? Why do I say this is, I'm very confident? If this length was 10, I'm pretty sure this length is going to be 7. If this was 10 centimeters, to me this looks like 7 centimeters. So that fraction of 7 centimeter to 10 centimeter turns into 0.7. I hope that makes sense. Separation techniques wasn't included in the syllabus? What? Really? What? Really? What? Really? I told you guys what the syllabus was in class a few times. Wasn't included in the syllabus? Okay. The table shows electronic structure of 4 atoms. 281, 284, okay, 281. Which 2 atoms combine to form a covalent compound? Which 2 atoms combine to form a covalent compound? Now for a covalent compound, you gotta have a metal reacting with a non-metal reacting with another non-metal. That's how covalent compounds work, right? Covalent compounds both have to be a non-metal to another non-metal. ठीक है. And if I figure it out, this is my metal because it's in group 1. How do I know which group? The valency is telling me what group it's in. It's same as the number, right? Now this is a non-metal. This is a non-metal. This is technically a non-metal. But the thing with this guy is it already has an octet rule. What do you call these? Noble gases. ठीक है. These are noble gases. They do not react. They undergo no reaction. So this is out. And metals do not form covalent bonds. So you have X and Y forming a covalent bond. ठीक है. Let me read this question again. Structure of 4 atoms. Which 2 atoms combine to form a covalent compound? Yeah, more or less. How do we know which makes a covalent or ionic? ठीक है. Which makes a covalent or ionic? ठीक है. Now the idea is, that's a question I'm not, last minute, chalo, understandable. ठीक है. You have, can I go to the periodic table? Where's my periodic table? Let me just add it over here. I'll quickly try to save. Good notes. Import to current document. This is your periodic table, right? You'll get a periodic table, by the way. Yeah, like, you know that. Okay, let me answer this and then go to chat. I think people have a bit of confusion. Okay. You got your group 1 and group 2 metals. Now the idea with these are the metals, because they only have 1 electron in their valence shell or 2 electrons, they're really, they can easily lose their electrons and have an inner octet completed, right? So they can easily lose an electron rather than gain electrons, because for lithium, let's say, it only has to lose 1 electron, or all of these elements really just have to lose 1 electron to have an inner octet completed, or like just their 8 outer electrons completed. And over here, it has to lose 2 electrons. So either an atom can lose its electrons or gain electrons to have an outer octet. And they all go for that octet, right? 8 electrons in their outer shell. Metals, because they always will lose, and if you lose or gain electrons, that can only happen during a chemical reaction. Metals, whenever they react with a non-metal, they form ionic compounds, because they lose it and give it to their non-metal counterpart, right? So instead of an exchange, a donation is happening. So metals, in summary, in other words, metals and non-metals, when a metal and a non-metal react, they will always form an ionic compound. Okay. And the other case is a non-metal reacting with a non-metal. Okay. They'll always form a covalent compound because both want to receive electrons, and instead of both trying to receive it, they share it in the same orbit, right? Covalent, like kind of like oxygen, how we ended up drawing like that, right? Let me just finish it. 2, 3, 4, 5, and my last O. Okay. And over here, it's trying to take electrons. The oxygen on the left is trying to take electrons from the oxygen on the right. And this is what the other oxygen is doing the same, right? So when they both do that, they form a covalent compound where they end up sharing the electrons, right? So an easier way of remembering it is sharing and donating. What about metals and metals? Probably someone is asking. Metals reacting with metals, well, they do not react. There's no reaction taking place. My face is not visible. I'm looking down. Hot dog, no. Hello, Manal. Because this is my class, Abdul Ghani. They have a test tomorrow. And yeah. Okay, I'm very thirsty. Disha was confused. Electron last shell, Y had so become stable, I think. Form a bond. Okay, she's fine now, I think. Sorry, not. Okay. Hassan Raza answered what I was trying to explain right now. He says ionic is metal and metal. No, ionic is metal with a non-metal, Hassan. And a covalent will be a non-metal to a non-metal. There's no reaction when it comes to a metal. Maybe that's what you were trying to type, or it's been some time and your revision isn't. Right? But that's what you do. And you just remembered some case examples, right? One really good example for ionic, the poster child, as I keep saying, for ionic compounds is sodium chloride. Hey, look, that's a metal with a non-metal. How do I know? Well, chlorine's all the way over here, and sodium's all the way over here. That's a metal with a non-metal. And on the other side, you have H2O or something, which is a covalent compound. You already know this. And look, it's a non-metal with a non-metal. Can I think of any other examples? Ammonia. Hey, that's a non-metal with a non-metal. I'm pretty sure that's covalent. Can you guys think of, I don't know, just chlorine itself? Just oxygen? You know, that's a non-metal with a non-metal, even though it's with itself. I checked thrice. Ramshad checked thrice what? Asked, sir, how do you know one makes covalent and ionic? Yes. Separating, I did mention it in a class. Like, we went over this a million times. Like, the myth, the legend, whomst. Did I say whomst? Okay. I think this is solved. The answer is X and Y. Right, if I'm not too confused. X and Y. This is horribly done. It's so ugly. Okay. Let's move on. Which statement describes the attractive forces between molecules? Intermolecular forces. Now, between molecules. Attractive forces between molecules. Let's highlight that. Intermolecular forces. We had a special name for those, right? The German name, if you guys recall it. They're strong covalent bonds which hold molecules together. This is more or less a revision on intermolecular forces. They're not ionic or covalent bonds. They're just weak forces formed between covalently bonded molecules. More or less this, man. They have it. They know it. Okay. But let's check this last part. They are weak forces which hold ions together in a lattice. Now, why can't it be D and why does it have to be C, right? How long is this live for? I'll do, there are 11 MCQs and a few, what do you call it, P2 questions, and that's it. Unless you guys have a question, I don't think I have the stamina to answer too many questions. But if you have a valid question, I'll try answering it. But I think over here, you have to understand when it comes to bonding, there are 4 different kinds of compounds or structures we study. In bonding, the most time spent, or like in order how we studied it, is the first thing we study are ionic compounds. Then we studied simple, I think probably not in this order, simple covalent compounds. The third thing we studied was giant covalent compounds. And the fourth thing was metallic compounds, just metallic only. And how ionic are, you guys probably know this the best. This is the most logical of all of them. If not, this is not straightforward, but the most logical. You form ions, a positive ion and a negative ion, right? Like sodium chloride. Sodium will be the positive ion and chlorine will be the negative ion. And they have this attraction between them. And it's not really shown like this because it just doesn't end between 2 ions. It keeps on going. So that's a negative, that's a positive. And we've drawn this structure a few times. And we keep doing this, right? And this is bonded like that. This is going to be positive, this is going to be negative, it's going to be positive, it's going to be negative, and they're all attracting each other. And this is a never-ending array of these particles, never-ending, right? Like it keeps on repeating. We're just only drawing a small segment because otherwise we won't be seeing anymore. Simple covalent structures are your molecules like water, right? What a water molecule is you have your oxygen molecule bonded covalently to 2 hydrogen molecules, right? And these are covalently bonded. These are strong bonds bonding it together. But that's just one molecule of water, and between these water molecules you have like many molecules of water, and between them there's a bit of attraction, and this attraction is very weak. So it allows water to be a liquid at room temperature, right? Simple covalent, and these are called simple covalent because these are tiny covalent compounds. They're simple covalent compounds, so it's like a very small molecule. Even bigger, slightly more complicated molecules are considered simple covalent, because the ones that are considered not simple are just millions of atoms, and we'll see that in a bit. Okay. And these forces have a particular name. You can call them intermolecular forces, but if you had to be very specific, these are van der Waals forces. Van der Waals forces. Or intermolecular forces is fine as well. If you guys don't recall this, remember the gecko example I gave you? A gecko is able to stick to a mirror or like anything very... You can't understand ratios? Okay. ठीक है. Okay. ठीक है. Giant covalent is like the older brother to simple covalent molecules. What do I mean by that? Is that how these have covalent bonds in the middle. This entirety of the structure is made of, all of these are covalent bonds. There's no weak intermolecular forces in the middle, right? This keeps on going as well. I don't know how well you can understand this, but this is a three-dimensional pyramidal structure, right? I hope you guys can understand that. A lot of diagrams are given to you guys. Okay. And this also allows it to be, so you can understand between the three of them, if you had to predict which of them would have the highest boiling point, right? Or which one of them would have the lowest melting or boiling point. You'd go with this because this has weak van der Waals forces holding it together, and that's what a state is, right? No problem, Fahad. Is that Ahmed? Ahmed who? Okay. You have weak forces holding these molecules together, so generally they're liquid at room temperature, like water and other oils, and oxygen is a gas, right? Ionic compounds have a really high melting boiling point, and so do giant covalent structures. Ionic compounds would be things like your sodium chloride, salt, table salt, and giant covalent are examples, are diamond and what else? Silicon, which is SiO2, there's a sand, and whatnot. These are structures for giant covalent. Okay. And metallic's probably the easiest, so we spent like 5 minutes on it. Metallic ion is, or like lattice is, just positively charged metal ions, because metals form positive ions over and over again. Very uglily drawn, if that's a word. You know, I was asked if relaxingly is a word. I found that hilarious. I just couldn't. I was asked during like one of my invigilation sessions if relaxingly is a word. You know who you are if you're here. But yeah, this is how you represent a metallic structure. You're not asked to draw this. You're only asked to sometimes to draw this, this, or this. Just saying, and you have to associate these diagrams or this, how they're arranged to their melting or boiling point. Just by knowing something is ionic, you should be able to tell, oh, it has a high melting and boiling point because it's ionic, it has strong ionic forces holding it together, blah. Right? That's the idea. Anyway, and same goes for all other things. Okay. Anyway, I'll go back to this. A little too much was spent there. Okay. And that's why, kids, the answer for this question is C. There are weak forces formed between covalently bonded molecules. That's what they were talking about. Said Loif. Can we restrict our talks again to chemistry related? I think some people might be struggling. Manal, I can't help you with the ratios right now. I think it's a little late. Maybe I can try doing a question if you have a question. There's another video I did doing moles on Saturday or Sunday, just the one before this. If you can't find it, let me know. I'll try to share the link. But I was exhaustively doing some moles questions. So try watching that. That's like a lot of... Yeah, Saturday or Sunday. I even sent a mail. To have a look at that. I got a dislike, nice. One EP left? What does that mean? So what are van der Waals forces? Now, that's what I'm trying to explain. They're weak forces between simple covalent molecules. Weak forces. The name of those forces is van der Waals forces only because the scientist, this German guy, van der Waals, discovered them. right? And think about it, why is water a liquid or a solid? If, like, we talk about ionic bonds holding it together, like, think about melting and boiling point, right? For anything. If something has a melting point, that means you're separating its atoms or ions or molecules away from each other. If you're separating something, what's holding it together? My Mac isn't charging. Sorry. Just gonna try and see why it's not charging. It's not charging. Because it wasn't powered on. Fair enough. Fair enough. All good. I'm gonna continue. I think nothing interrupted us aside from my silence. I hope the audio is fine. I hope everything's fine. Everything is fine except for my hair. Look at that mess. Look at that mess. ठीक है. Let's come back here. The diagram represents the general structure of a solid Z. What do you think this could be? Like, there are 4 kinds again, and we're like, we drew each one of them right now. I think this question should be really easy. Which could this be? Oh, they're not telling us the names of the type. They're asking for, oh, I thought it was something else. I highlighted the wrong diagram. But, okay, what could be Z? What is this structure Z? So, is this aluminum? I was thinking it's some ionic compound, because to me it looks like an ionic compound. I'll try to find an ionic compound over here. Aluminum, that's a metal. Iodine, that's I2. Silicon dioxide, that's a sand, right? That's sand. A giant covalent structure, that can be it. It would look like that pyramidal thing we just drew. Sulfur, oh, that's simple. That's just a pure element, right? Now, my issue over here is none of these are ionic. This, to me, on first glance, looked like an ionic structure. But what they're trying to highlight is not this structure, but they're trying to highlight this structure, and instead of E's, how I'm used to seeing them, they've drawn the electrons as tiny little. Yeah, so that got me confused just because, and they're talking about aluminum right now. Aluminum's the only one. So, like, it's just matching pictures at this point. Like, like, which of the 3 or which of the 4 could this be? And if you, like, they won't give it to you. You have to remember these. But eeny, meeny, miny, mo. And you have to then figure out which of these 4 could be metals. Okay. The particle, let's do the next question. The particles of a substance gain energy and change from regular ordered structure to a disordered structure with large distances between the particles. Which change state is described? Boiling, evaporation, melting, sublimation. Now, particles of a substance gain energy, right? So it's being heated up because it's absorbing energy, so it's heating up. The change from a regular ordered structure. What's a regular ordered structure? What, qu'est-ce que is a regular ordered structure? That's a solid. And to a disordered structure with large distances between the particles. And what is that? A disordered structure would be liquid, but with large distances between the particles is a gas. They're talking about a gas. So essentially, they're being idiots, and they're saying, what's the process called of a solid turning into a gas? That's what the question is. And I think the answer is sublimation. Sublimation. Yeah. ठीक है. Yeah. Don't get this question wrong, guys. This diffusion question. The diagram shows an experiment to demonstrate diffusion. You have cotton wool soaked in hydrochloric acid, and on the other side you have cotton wool soaked in ammonia solution. And even before reading the question, you can tell the reaction is taking place here and a cloud forms. Why is it forming closer to the hydrochloric acid than the ammonia? Ammonia is NH3. A good thing to know is some of the popular gases names you should be able to, you should know at this point because we've talked about them a lot, so does the exam. The MR for hydrochloric acid is 36.5 and the MR for NH3 is 17, I think, if I'm not too wrong. So if you notice, this is lower than half its mass per molecule, right? It's the relative molecular mass I just calculated. So between the two, this is going to travel much faster. So at the same time, if hydrogen chloride covers this much distance, which is very small compared to ammonia, ammonia covers a lot larger amount of distance because it diffuses faster, right? And that's what's going on. And which statement will explain why the ring of ammonium chloride, this ring, the reactant, the product is ammonium chloride, appears as shown. Ammonia's solution only produces a gas which moves until it meets the hydrochloric acid. I don't even know what it's saying. Ammonia solution only produces a gas which moves until it meets. Oh, okay. Yeah, I don't fully understand what the English over here is. Maybe I'll come back to this. Maybe I'm just tired. Both solutions produce a gas. Okay, yeah, okay. But ammonia moves quicker than hydrogen chloride because it's lighter. Yeah, that's more or less what's going on. I thought they would ask about diffusion. B is my best answer out of A and B. Let's see C and D. Hydrochloric acid produces hydrogen chloride. What does that mean? What are they saying? Okay, I guess I know what they're saying. Hydrochloric acid produces hydrogen chloride, which stays at one end of the tube until the ammonia reaches it. Well, it's not staying at one end because it also moves, right? The reaction is happening here. That means there's hydrogen chloride over here, ammonia over here. This is where they meet, and the reaction forms a white cloud. The two solutions run along the tube until they meet. That's true as well. But this is the most apt explanation, right? Both solutions produce a gas, but ammonia moves quicker than hydrogen chloride because it's lighter. And yeah, I think between D is also correct, but yeah, like B is more descriptive than D. I don't see anything. Oh, the solutions, that's what they want. That's a stupid question. The solutions aren't running. So what's happening is these two cotton balls are soaked in the solution and you leave them and they evaporate and turn into a gas and then they're meeting. And to say solutions meet is wrong because it's not the solution meeting. It's actually the gas meeting. So that's what's wrong with D. So D can't be an answer. And yeah, I think if you take question as a whole is really stupid, but if you take D away from it, the question is more or less reasonable, an easy question otherwise. What do you guys think about question number 8? Lightning McQueen Gaming. Let's boycott this question. Whose dudes is that? Hey Miral, how you do? Okay, shall we continue? Any other questions so far? It's okay. I don't care about the dislikes. I'm just, someone swore in the chat. I think that's just a, I'm just incredibly tired. Take it, it's okay. I do want to drink water. Yeah, Disha, it's coming, dude. Like, what are you asking? Chapter 1 is coming. It's kinetic theory. Like, it's coming in the test. ठीक है. Particles moving very slowly from an area of higher concentration to an area of lower concentration. Which process is being described? A liquid being frozen. Higher concentration, isn't that diffusion? A liquid being frozen, solid melting, a substance diffusing through a liquid, a substance diffusing through the air. Particles moving very slowly from a higher concentration. ठीक है. I think the very slowly is highlighted. So between C and D, you're more likely to pick C because in air, because they're more agitated, the particles, they have more energy, they're more excited, they're not as slow. Okay, so between C and D, C is the better answer. So it's a better answer rather than the correct answer, I say. I have a... Yeah. Okay. Question number 10, dot and cross diagrams. Which diagram shows the arrangement of an outer shell of electrons in the molecule of methanol? So this is methanol. Okay. Which could show it. So if I take a closer look at this, if I try to draw the dot and cross for this, hydrogen will only have 1 electron. Carbon has 4 electrons around itself. Are they using different colors? Yeah, okay, different shapes. Let's do that. And then you have oxygen, which has 1, 2, 3, 4, 5, 6. ठीक है. And hydrogen has, I think carbon को इन्होंने X use किया, so we'll use the same thing. Carbon has 4 electrons, and each hydrogen has 1 electron each. So they have 1 bond over here, right? Between this hydrogen and this carbon has 1 bond, so that means they're sharing 1 pair of electron. So if I try to do that between them, that's 1. And similarly, that's the same for these two. So I try to do that. I take their electron and their electron like that. ठीक है. Now carbon and oxygen have a double bond. So 2 electrons are being shared with 2 electrons of this, much like how we saw with carbon dioxide. ठीक है. And just to make it neater, I'll take this here. And this is it. And if I try to draw circles around it, this is what you would have. And if I'm the closest one right now I am to is B, and this electron is telling me this is incorrect. Because hydrogen will have only 1 electron that's shared, won't have another electron. It's hydrogen, right? And this looks correct to me, but they only have 1 single bond over here. And another way of looking at it is that if you look around oxygen, it won't have 8 bonds this particular way. So 2, 4, 6, 7, 8. Wait a minute, what? 2, 4, 5, 6, 7. Yeah, can't count. ठीक है. 4. C is our answer, isn't it? C is exactly the same as D, but with the correct double bonds. Like that. A is incorrect because it's not showing oxygen bonds. So it's one of those questions where like half the options are, easily gone because, oh, A is gone because it doesn't have oxygen outer electrons. That obviously needs to be there. And B is not it because hydrogen has too many electrons than it should have. Then there's D, and you try to take a closer look, and like you're just comparing, this is the only difference between these two. And you go like, they don't have 8 electrons. So you didn't even have to do this. I just did it because some people might, wanted to learn the dot and how to make the dot and cross for this. But you don't have to do this. You can just easily eliminate everything until you're left with C. Okay. The real Abdul Ghani. Are you the real Abdul Ghani? Oh, okay, I get it. Guys, stop. He's been following me. He's been watching some of my videos, especially on the other channel where I'm making videos. He's not the real Abdul Ghani. Stop it. Stop. Be a little more welcoming to other students. Abdul Ghani, why do you say student and then dot dot? Are you not my student? I don't like Abdul Ghani. I don't know. Bro, Lama. Manal, you're so active online. Okay, last MCQ for the day. Oh, balancing equations. Yay. Equation for the reaction between phosphorus and oxygen is shown. Which values of x, y, and z balance this equation? You can just try it out, right? Now, if I have if I put 1 over here, 5 over here, and 2 over here, how many atoms do I have of each on the left-hand side and on the right-hand side? So let me rewrite this equation because I don't have enough room to play around. But I wouldn't encourage you guys to do it when you're doing it in your exam. Okay. And if this is 1 and this is 5 and this is 2, I think we're balanced because you got, you have P and O, right? You have 4 on the left hand side and you have 4 on the right hand side. You have 10 oxygens on the left hand side, you have 10 oxygens on the right hand side, and it's balanced. The first one is balanced. Now if you try to do it with anyone else, 1, 10, 2, if you have 1 and 10 of this, you'll have 20 oxygens here and still have 10 oxygens over here. So that won't work. 2, 5, 2, you'll have you'll have 8 phosphoruses here, but 4 phosphorus over here, and that won't do with the 2 and 2. And with D, 2, 10, 1, I think you'll have both of these incorrectly. So you'll have 8 of these and 20 of these, whereas over here you'll have 4 of these and 10 of these. Oxygens. Why am I saying these? 4 phosphorus and 10 oxygens. ठीक है? Yeah, so X and Y I'm replacing with the numbers, and we're working it out that way. This ain't algebra. Say that in a Texan accent and I'll give you full marks right here, right now. Like a deep Southern accent, like Red Dead Redemption 2 from Arthur Morgan accent. You all know I can't do it. I'd love to do it. Table below is giving us information about particles. Complete the table. The first line has been done for you. So particle A, we don't know what it is, has 12 protons, 10 electrons, and it has lesser electrons, so it has a charge on it, right? What would be the charge on it? 2 plus, that makes sense, and electronic configuration is 2, 8. We could have figured that out. It's not a challenge. Okay, let's try to figure it out over here. You have a charged particle which has an electronic configuration of this and 18 number of electrons. So let's say there's an B is some ion with a negative charge, and it has right now currently how many electrons? 18 electrons. So B, as not a charge but an atom, will have how many electrons? You'll lose one electron because right now it's an ion, right? Right now it's an ion, one extra electron. So one extra means from 18, one extra. You take the one extra away, you get 17. So as an atom, it'll have 17 electrons. And as an atom, if it has 17 electrons, it should have 17 protons. Does that make sense? Over here, you have 0 charges and 18 protons. So, you know, it's just an atom and it should have 18 electrons. And another way to confirm is you have the electrons given to you. 2 in the inner shell, 8 in the middle shell, 8 in the outer shell. It's a noble gas. Oh, by the way, this is not a noble gas. I think this is fluorine or chlorine. 2, 8, and 8. 2 plus 8 is 10, plus 8 is 18. Okay, this is the real challenge. You have 8 protons, 10 electrons, right? So I know it has a charge of 2 negative because it has 2 extra electrons. And notice how I'm putting the charge exactly how it's given to me in the table. If you write -2, I'm going to give you a incorrect because you match how it's written over here, right? No excuses. And how would I write its electronic configuration? It always goes in the formula 2, 8, and 8, right? So 2 to begin with, I'm left with 8, and I think I'm done with all the electrons I have. Okay. And if you're confused, if you're supposed to give the electronic configuration of the atom or the ion, over here, have they given us the electronic configuration of the atom or the ion? They've given it for the ion because it has a negative charge and 18 electrons. The atom would have 17 electrons, so this would have been 2, 8, 7. Okay. I just used everything else in the table to complete the data. Very little understanding of, I think, chemistry was required right now. Very little. You just needed to know the orbital thing, and I think a little bit of charge maths could have told you everything else. Okay. Define the term element. It's a matter or something with only one kind of atoms in it. It's made up of only one kind of atom. It's made up of, I'll get a nicer color. It's made of, an element is made up of only one kind of atom. Take it. That's the simplest explanation, and it's a 1 mark. We don't have to be too verbose about it. I'll try your best to answer according to the word. Each statement would result in 1 mark. All right. Can I get a 2-minute break while you guys try this question out? What do you guys think? I'll just try going over some comments. Disha still says to reply. 18 for C, 17 protons. I'm not. Disha, can you question semicolon or like colon and like just ask the question? For C, 18 and 17, I'm not following what the question is. We cannot say a simplest form of an atom because no, that's just wrong understanding of what an element is. An element is something that's pure, right? And the easiest way to talk about something that is pure is just like it's the only element in it, right? And it's only the same kind of atom. That's what makes the... Adisha, I'm not answering that question. What's important for tomorrow? I think moles would be like the bigger chapters are just taking more spaces. I've tried my best to test everything. There is moles. There is, yeah. This is a good representation of what the paper is. Okay, how do we do this? These are the number of protons over here. I forgot to take my break. These are the number of protons over here, and this is the nucleon number, or the sum of whatever's in the nucleus. And what you have in the nucleus is the neutrons plus the protons. So let's be easy on ourselves and just say 31, 31. Electrons will remain the same because they don't have a charge on them. 31, 31. And what are the number of neutrons? This is the sum. And I just take the number of protons away from this number, and I'll be left with the number of neutrons. 69 minus 31 is 39, 38. 38. Awesome. 71 minus 31, that's 40. Someone verify? Someone confirm? 2,8 for C. For C. Oh, I was looking at a very old question. Rude but true. Who are you? Lol. I don't know about anyone, but Disha's been getting full marks in like last 3 exams, and what's actually like low-key, making me upset is she doesn't even come to my classes. And like, wow, this child is a genius or something. But oh well. Okay. What does IBS mean? Because it means something else. Like go back to Mexico. Super Striker is not. I think he's not adding valuable things to our discussion. Not enjoying his comments. Who is he? Welcome, Afan. That's why we can't have... Can you guys just report people who are just, No, you don't, Disha. Come on. Not all of them. Maybe you do. Am I wrong? No, you don't. Come on. Don't lie. Or maybe I can't remember, but I'm pretty sure you have low attendance. Don't you? I don't know. Again, I'm not 100%. You might be right. I don't know. Carbon dioxide. Complete the following table. And you have to understand that carbon dioxide over here is a simple covalent molecule with weak van der Waals forces holding it together. Ban, sir, have no fear. I did ban him. I think so. Do you guys still see Super whatever Striker, whatever his name is? I'm trying to ban them. I removed him. I don't know if it's... You guys can still... Who's Kirpa? Oh yeah, Kirpa does that. Yeah, Kirpa though, definitely. She hasn't showed up in 4 months. What the heck? But I think you were also doing that a bit right at the end. But oh well, it doesn't matter. If you're getting good grades, I don't care. You can do what you want. As long as you're being civil. I think that's what needs to be said. A bit of decency. Now, yeah, what I was saying was carbon dioxide. You have to appreciate that it's a simple covalent structure. How would you know that? Sheer memory. You look around, hey, carbon dioxide is a gas. It has to be what sort of structure out of the 4? Only one of them can be gases, and that's simple covalent. And silicon dioxide is a giant covalent sand. We can't keep talking about it. So this is CO2. I love the screen. Physical state. If you can't figure it out that it's going to be a solid, because sand is a solid at room temperature, hello, you can maybe work it out with the melting point. If it melts at 1600 degrees, anything lower, and 25 degrees is way lower than this, you can tell that it's going to be a solid at room temperature. Conduction of electricity, as giant covalent structures do not conduct electricity at all. Non-conductor. Structure, macromolecule, and simple covalent. Covalent. Name the type of bond that exists between atoms in silicon dioxide. What type of bonds are in silicon dioxide? We're ending this soon. We don't have too much time, I think. How much time have I taken? What time is it? It's not telling me the time. Can someone let me know what the time is? Let's try these questions out. I'll take a breather. The AC is really dry, which is making me very thirsty. I'll be right back. How do I pause my video? Camera. Sorry. Why can't I pause my video? Bloody. Should be aware to pause my video. Oh well. Okay, name the type of bond that exists between atoms of silicon dioxide. Well, covalent bond. Cool. Explain why silicon dioxide has a very high melting point. It is held together by it is held together by covalent bonds. Now there's one more question. I'll answer as if it was a 2-mark question, just in case. And each color is it is held together by covalent bonds. Actually, I'll say strong covalent bonds. I like that adjective to use with covalent bonds. Strong covalent bonds that require a lot of energy to break or separate. Okay. Explain in terms of attractive forces between particles why carbon dioxide has a very low melting point. So same answer. If you appreciate, I'll say the same thing over here. I'll actually just copy this and I'll paste it here. Actually, let me tell you guys what it is held together by. Strong covalent bonds that require lots of energy to break. That's it, right? That's everything else is just, English. Or क्या बोलते हैं सर? Subject object होता है. The rest of the sentence is what? अबे? Subject object in a sentence. Everything else, like what do you call them? The other filler words. Dude, can you paste? And just appreciate what I'm doing over here. It is held together by weak van der Waals forces that require little energy to break. Energy to break or to overcome would be a better word. Okay, and look what I did here. Weak van der Waals forces instead of strong covalent bonds. And it's the same question talking about two different things. So because it has weak van der Waals forces, the energy required is very less. So you can easily break them apart or else change their state. Sir, intermolecular forces are only in liquids? No, that's the wrong way of looking at it. if something has weak forces holding it together, generally it won't be too stable. So either it'll have a very low melting, so generally it'll have a very low melting and boiling point. So some solids which are that easily melt, like plastics will easily melt if you heat them, are simple covalent structures with weak van der Waals forces. Liquids, more or less all the time, because you know they have weak van der Waals forces, will be simple covalent structures. All gases are more or less simple covalent structures, right? I hope that makes sense. Little. And that's what I changed over here. And I didn't like the word break to use with van der Waals forces, so I just changed it just because of thing. But if you write break or anything, that's, well, not fine, but like no one is gonna come after you. Take it. Explain in terms of particles why carbon dioxide is a non-conductor of electricity. And every time you see something like this, you just say what? What do you say? What? Can't hear you. You say no free moving electrons. ठीक है? Easy? Ah, the real challenge. The real challenge. Did I say algebra? Didn't I say something? I'm taking a selfie. Or like, it's not a selfie. I could take a selfie. That's too stupid. Taking a picture for a friend. They were asking what I was doing. She's one of my older students from A levels. ठीक है. Someone's a favorite student. ठीक है. The diagram shows the structure of hydrazine molecule. Draw the electron arrangement of a hydrazine molecule. I'm just Irish. No, I said southern accent. Okay, I'm gonna not use that phone again. Sorry, I am wasting some people's time. Some people who probably really want to sleep. Sorry about that. Again, sorry about the late class. But again, it's an optional thing. You don't have to. ठीक है, I'm trying to draw the dot and cross for this. Now, nitrogen, I realize, has 5 electrons in its outer shell. And it needs to bond 3 times. So it makes 3 bonds. I've seen ammonia enough to know this really well. So here's, I really like that blue, how it's coming out. Or, you know, here's a cheat how I do it, ensuring I would make no mistakes. ठीक है. The lines I would draw over here would be with pencils. Now each bond over here is drawn with what? Each bond over here, I'm exhausted. Each bond over here is drawn, represents 2 electrons which are being shared. So between each line, I'll make sure I draw a dot and a cross. And over here, there's only 1. ठीक है? And each nitrogen has, the circle are meant to be nitrogens, though each nitrogen has 2 electrons on either side. And I'll then remove the lines. ठीक है? I think I erased something extra. You know, this is more or less a क्या बोलते हैं सर, hack of sorts, like a um, क्या बोलते हैं, what's that word? Guys, try your best to make this neat. Probably I'm not the best example, but it just looks so much nicer when it's neat, and it's very, not confusing. I shouldn't probably be saying those things. If I can draw it neat. Why did I do that? Oh, that fits. It looks silly. I should have tried doing it a different way. Take a dot and cross. Let's try the next question out. I think this is a repeat. No, okay. It's not a repeated question. Element we defined, right? So we'll skip. Oh, it's not here. I'm looking at the wrong question. Why is this here? I wasn't really looking at this, so I never changed the page. Yeah, there we go. Smart too, big brain. She built different? Okay. I said I won't be looking at my phone, but it's 11:30. I need to look at my phone. Relative mass for a proton is 1. Neutron is 1. Relative charge is +1. Electron is -1. Neutron does not have a charge. To find the term isotope, Sami, what is isotope? It is same atoms with, well, atoms of the same element. Let's go with that. Atoms of the same element with different number of what? Neutrons. ठीक है, explain why two isotopes of bromine have the same chemical properties. Chemical properties rely entirely on their electronic configuration. They have the same electron, both have same electronic arrangement. I don't know about you guys, but isn't my color choice just arrangement? My color choices, man, look at that. No, I don't think so. Sir, did Sir tell anything about the exam? Ha ha ha. Hey, Rooch, what's up? How's it going? What's up? What is up? What is up? Yeah, okay. I'm getting messages. Okay. Why did I put so many of these? Can I skip this? I'm just so tired. Let's do it real quick. If you have a question, you can ask. Number of protons is 3 and 16, and number of neutrons is 4. 34 minus 16 is 30. What is it? 34 minus 16. 4. Take this 4 away to 28. 18. I think it's 18. Number of electrons, it has 3 electrons. This has 16, 17, 18 electrons. And 19 protons, I think that's fluorine. No. I have to look at the periodic table. What has 19? Why don't I know this? 18 would be, okay, 19 would be sodium or potassium, right? Yeah, potassium, like that. I'm smart too. Smart too. And just for kicks, I'll write down what they have written down. 11 over here and 39 over here. Okay. Now, if you look at the periodic table right now, it's by the same people, right? Now, over here, they ended up writing the number of protons niche and the number of the nucleon number or the mass number, right, on top. They keep changing it. I don't know why they do that. Why don't they have consistency? On the periodic table, it's ulta. Like potassium is actually K11 on top and 39 at the bottom. I don't know why they flip it. I wish I knew. I think it's very unfair. Especially with like O levels, because people find these things confusing for like because they haven't been used to it before O levels. But just know the smaller number is always the number of protons or the atomic number, and the larger number is the nucleon number or the sum of protons and neutrons, right? So one number has to be the sum of neutrons and protons. One is just the proton number. So the sum has to be larger than the one. You know what I mean, right? And that's how I remember it all the time. If you get that, you'll never be confused between proton numbers and nucleon numbers or mass numbers. Calcium phosphate is used in Okay, ionic. What is ionic bonding? It's the electrostatic force of attraction. This is more or less what the attraction between two oppositely charged. Good thing, if you remember this, it's a good thing because this is going to carry all the way till A levels because they really like asking this question. Well, not really, but it does show up there. Electrostatic force of attraction between two oppositely charged ions. And it makes absolute sense because if you look at sodium chloride or that picture I drew, the bond is essentially, where is it? The bond, this ionic attraction you have, is because these two are oppositely charged, and this is the attraction between them, the positive and the negative. It's electrostatic, much like static electricity. It's just that they're so close that energy is way larger. And that force is way larger. We did quite a few questions. Define the atomic number. I just said this like seconds ago. It is the number of protons. The atomic number on the periodic table is given to a particular element because it has that many protons in it. Number of protons. Nucleon number, sum of protons and neutrons. Skipping part B, and I think we're done. Skipping part B. We are done. Manal is, wow. What's Ibrahim saying? Then saying late night epiphanies thing make it sound sus. Any questions? Who's Leo? I think you told me Leo. I just forgot who you are. Sorry. I think I know Manal Jangir is Manal, much less because of her name, but more because she has a cat in the picture. I'm ignoring everyone today because I'm just dying. I wanted to do this 3 days ago. I haven't slept. I was talking. Thank you, Sheza. Color choices, yeah. Okay. Any last minute questions? I am ignoring. Sorry, I'm just so done. I'm so sorry. Not even feeling well. There's like a team. We're sitting there. We're working. We're trying to make something awesome for you guys. Maybe we'll have it running next week or the week after. And I'll invite you. It's a platform I'm working on, and I'll invite all of you. You can use it. Are we done? We are done. The cat. ठीक है. I don't think we're done. Disha is always like, Are we done? I'm leaving. I think that's what I was thinking rather than you bunking my classes. Like, are we done? I'm going. You know? I can't ignore anyone. Can we do a mole? I did like 40 minutes of moles with the last class. I'm just so done. Please? Don't say please. I'll probably do it then. I can't. I'm gonna take care of myself, like Manal was saying. I'll listen to her. ठीक है. Yeah, I'm gonna. This, like, I explained it in another video. There's so many videos on moles. I swear to God, they're there. You know, believe me, they're there. Like, just, I think you just didn't watch them or something. It's already there. I don't want to spend any more times on moles. It is hard, but I think there was some consistent effort needs to be shown. Ibrahim, on the other hand, was showing a little lack of dedication, I think, throughout our time doing moles. So I'm kind of like a little less motivated to go over moles right now. ठीक है. But with that, can I just say bye-bye? Good luck tomorrow. And please don't cheat or anything. You know, like, don't be that guy. You guys have seen me invigilate. You guys know I don't like it when people cheat. If you don't know the paper, maybe we can figure something out. But if you're cheating, if you're caught cheating and if the invigilator says take 5 marks away, I won't do that. I just won't check the paper. Do not cheat. ठीक है? If you don't know it, you don't know it. Fine, it's okay. It's not the end of the world. All of you are going, you know, like, there's no loss, is there? ठीक है. Well, let's end it here. Bye-bye, guys. Take care. Bye-bye. You guys can put some comments. I'll try to answer them, but I won't make any more videos or do a solution. You're welcome. Bye-bye. Take care. I hope you guys had fun. I hope I didn't make you guys stay up late. I hope this reduced your anxiety for tomorrow. I hope so. ठीक है? Okay, bye-bye, guys. And if some people haven't seen it, please make sure they see it. If they didn't look at the mail because it was a little late, just let them know. ठीक है? Bye-bye, guys. Take care. Take care. Have fun tomorrow. Lol. Or after the exam, because after that. Yeah, have fun after the exam tomorrow. Bye-bye, guys. Take care.